Have you ever pondered why celestial bodies, from the tiniest of asteroids to the largest of galaxies, are always in motion? This is the fundamental question that we will explore today. We'll delve into the Cosmic Ballet, where planets pirouette, asteroids and comets streak across the sky, galaxies waltz through the cosmos, and the universe itself expands in a grand choreography. It's a dance on an unimaginable scale, but why does it happen? Join me as we embark on a cosmic journey, unraveling the motions of celestial bodies. Imagine our solar system as a grand cosmic ballet, with each planet performing its unique dance. Each planet pirouettes around the sun, tracing an invisible path known as an orbit. From Mercury, the prima ballerina with the fastest, tightest twirl near the sun, to Neptune, the danseur noble performing a slow, majestic sweep on the outer stage. Each planet's dance is distinctive. Their movements, though, are not random improvisations, but follow a precise choreography laid down by Johannes Kepler in the 17th century. Kepler's laws of planetary motion are the director's instructions that govern this celestial ballet. The first law, or the law of orbits, tells us that planets move in elliptical orbits with the sun at one of the two foci. Not perfect circles, but ovals, allowing for the ebb and flow, the coming and going of planets from the sun. The second law, or the law of areas, describes the speed at which the planets dance. They quicken their steps as they approach the sun, and slow their pace as they recede, yet maintaining a constant area sweep for equal time intervals. The third and final law, the law of periods, correlates the time a planet takes to complete its dance, its orbital period, with its average distance from the sun. Simply put, the farther a planet is from the sun, the longer it takes to complete its dance. So each planet, while performing its unique dance, adheres to these universal laws. From the swiftest twirl of Mercury to the languid waltz of Neptune, the rhythm and pace of their movements are all dictated by their distance from the sun and their orbital shape. This cosmic ballet, though seemingly chaotic, follows a strict choreography. The planets are not merely celestial bodies caught in a dance of time and space. They are performers adhering to a grand design, a set of rules that govern their every move. It appears that planets are not just aimlessly wandering, but following a set of cosmic rules. Not all celestial bodies follow the same dance steps. In the grand ballroom of the cosmos, asteroids and comets are the unpredictable dancers, their paths tracing irregular patterns across the sky. If planets are the disciplined ballerinas, then asteroids and comets are the freestyle artists, each with a unique signature style. Asteroids, often referred to as minor planets, are rocky remnants left over from the early formation of our solar system. They follow eccentric orbits, moving in a somewhat elliptical path around the sun. The gravitational pull of nearby planets, especially Jupiter, can significantly influence their motion, causing them to veer off their original course. Comets, on the other hand, are icy bodies that originate from the distant regions of the solar system, like the Kuiper Belt and the Oort cloud. As they get closer to the sun, the heat causes their ice to vaporize, creating a glowing coma and sometimes a spectacular tail. Their orbits are also influenced by gravity, but in a more dramatic way, due to their elongated orbital paths. A famous example of a comet is Halley's Comet, named after the English astronomer Edmund Halley. He was the first to realize that comets were not just random apparitions in the sky, but followed definite orbits. Halley's Comet, with its highly elliptical orbit, takes about 76 years to complete one trip around the sun, providing a spectacular show for Earthlings once in a lifetime. These irregular orbits of asteroids and comets are not without purpose. They may seem like rogue dancers, but they're actually following the cosmic laws of motion, their paths dictated by the gravitational forces at play. Their seemingly erratic movements are a testament to the complex and beautiful choreography of our universe. So, even the most erratic dancers in our celestial ballet are performing to the tune of gravity. Their dance may seem random and unpredictable, but it's all part of the grand cosmic performance, a testament to the intricate and awe-inspiring nature of the universe we inhabit. But what about the stars? Are they also part of this cosmic dance? Indeed they are, and their dance is quite a sight to behold. In the grand ballroom of the universe, the stars waltz across the cosmic floor in a rhythm set by the laws of physics. Each star is a celestial ballerina, moving in harmony with billions of others in a performance that has been ongoing for billions of years. Imagine a galaxy, such as our very own Milky Way. This isn't a static, unmoving structure. No, it's a dynamic, spinning entity, much like a colossal cosmic carousel. It rotates, and with it, all its stars rotate too. Picture it as a gigantic luminous whirlpool, with stars swirling in its spiral arms. The speed of this rotation isn't uniform across the galaxy. Stars closer to the center whirl around faster than those on the outskirts. This is due to the gravitational pull of the galactic core, a dense region packed with stars, dust, and perhaps a supermassive black hole. Yet, despite these different speeds, the stars maintain their relative positions. This is because the gravitational pull between them keeps them in check, much like partners in a waltz, holding each other in a perpetual dance. The Milky Way, like other galaxies, also moves through the universe. It's part of a local group of galaxies that are gravitationally bound together, dancing their way through space. But this dance isn't just about rotation and revolution. Stars also bob up and down as they orbit the galactic center, like horses on a merry-go-round. This motion is due to the gravitational pull of the galactic disk, a dense layer of stars and gas. So, stars are indeed part of the cosmic dance, twirling and waltzing across the galactic stage, driven by the universal laws of gravity and motion. They are performers in the grandest ballet of all, their movements choreographed by the unseen hands of physics. Even at the grandest scales, the universe is a stage for this cosmic ballet. But the cosmic dance isn't confined to our galaxy alone. You see, just as the planets pirouette around the sun and the stars swirl in the arms of our Milky Way, galaxies too partake in their own grand waltz. They're not static, but in fact constantly on the move, journeying through the vast cosmic sea. The stage for this performance is the universe itself, and its expansion is the rhythm to which galaxies dance. This expansion of the universe was first observed by astronomer Edwin Hubble, who found that distant galaxies were moving away from us in all directions. This discovery led to what we now know as Hubble's law. The further a galaxy is, the faster it is moving away from us. This implies that the universe is expanding uniformly, like a loaf of raisin bread rising in the oven. The raisins, or galaxies in our case, move farther apart as the dough or the universe expands. But what's driving this continuous expansion? Enter dark energy. It's a mysterious force that we can't see or directly detect, but we know it's there because of its effects on the universe. It's like the invisible puppeteer pulling the strings, causing the universe to not only expand but to accelerate in its expansion. Dark energy is thought to make up about 70% of the universe, dominating over matter and dark matter. It's this dark energy that's causing galaxies to move away from each other at an ever-increasing rate. And though we don't fully understand it yet, it's clear that it plays a vital role in the cosmic choreography. So, the next time you look up at the night sky, remember that what you're seeing is not a static portrait, but a dynamic, ever-changing panorama. The stars, the galaxies, the entire universe are all in motion, performing a cosmic ballet on a grand scale, choreographed by the laws of physics and propelled by dark energy. As we can see, every part of the universe is in constant dynamic motion. So, what choreographs this grand cosmic dance? Well, the answer lies in a delicate interplay of factors that govern the universe. Let's start with gravitational forces, the invisible strings that pull celestial bodies towards each other. Imagine a solar system as a grand stage, with planets, moons, asteroids, and comets all enacting a cosmic ballet under the direction of gravity. This invisible force ensures that the dance partners maintain their perfect orbits, moving in a flawless synchrony that's been perfected over billions of years. Next, we have the fundamental laws of physics, the rules of the dance. They dictate how celestial bodies move, interact, and influence each other. Take Newton's law of universal gravitation, for example. It explains why the apple falls from the tree and why the moon orbits the Earth. These laws are the choreographers, dictating every twist, turn, and pirouette in the cosmic dance. Lastly, we have the enigmatic dark energy, the unseen force that's causing the universe to expand at an accelerating rate. It's like a cosmic tempo, setting the pace and rhythm of the universe's expansion. This mysterious entity is constantly changing the dance floor, making the cosmic ballet ever more dynamic and intriguing. And so, we find our answer. The cosmic dance is a complex choreography of gravitational forces, cosmic laws, and dark energy. The universe, it seems, is a cosmic dance floor, with each celestial body performing its part in the grand ballet of motion.